Earth, a 4.5 billion-year-old planet, still evolving. As continents shift and clash, volcanoes erupt, glaciers grow and recede. The Earth's crust is carved in countless fascinating ways, leaving a trail of geological mysteries behind. Water, one of the most powerful forces on the planet. It plays a crucial role in creating life and destroying it, in forging landscapes and in breaking apart the Earth. In its most dramatic form, it becomes a killer wave known as a tsunami. Until recently, predicting when these monsters may next strike has been impossible. But today, scientists are starting to understand these giant waves by connecting clues as varied as ancient Japanese writings and landslides, ancient corals, and buried Native American settlements. The secrets of tsunamis are finally being unlocked. Tsunamis, one of the most deadly forces of nature. Giant waves that travel faster than a jet plane. They can cross entire oceans in just hours. They have the power to smash buildings, vehicles, anything in their way.
By itself, you wouldn't think that water just streaming into the coast would necessarily cause so much damage. But in fact, they are very fast moving and they pick up everything in its path. So it's not the water by itself, it's what comes with the water that is also a part of the big hazard.
A tsunami isn't over in just a few seconds. It is a torrent of raging water that keeps coming.
The main thing about a tsunami is the persistence. It comes on and on and on, and just when you think it has to quit, it keeps coming. And it's the power plus the duration that is unstoppable, really.
Tsunamis have ravaged the Earth for billions of years. When the Earth was first created, the moon was much closer. It filled the sky. Its gravitational pull was much stronger, and it generated towering waves over half a mile high that raced across the primeval oceans. Today, tsunamis are still a threat to coastlines all over the world.
Tsunamis will always occur and have always occurred throughout Earth history. But it's only been more recently, as population densities have increased and people have moved and migrated to the coastal regions, that we've become much more aware of the tsunami hazards.
The investigation into what caused these monster waves began over 1,000 years ago on the islands of Japan. This country is the world's tsunami hotspot. Its coasts have been pounded with these enormous waves more than anywhere else on the planet. Evidence for this is the word tsunami itself. It is Japanese and literally means harbor wave. Japan has the longest written tsunami record of anywhere in the world. The records go back as far as 684 AD. By studying these records, it is possible to work out that, on average, this country has been struck nearly every 7 years. Samurai writings speak of people living on the coast running for higher ground as soon as they felt an earthquake. The Japanese knew this was a clue, a warning sign that a deadly tsunami would soon follow. But despite their attempts to escape, tsunamis have continually brought death and destruction to these islands. In 1896, a wave that hit Honshu in the northeast claimed the lives of 27,000 people. In 1933, the same area was smashed again. This time, 3,000 people were swept away. And in 1993, The island of Okashiri was rocked by an enormous earthquake measuring 7.8 on the Richter scale. Buildings were leveled and fires raged. But worse was to come. Minutes after the shaking had subsided, an ominous white crest appeared on the horizon. A tsunami. A gigantic wave swept in, flattening any buildings still standing. In Japan, the locals had already worked out the connections between earthquakes and tsunamis. But there's another hotspot on Earth where tsunamis regularly strike: the Hawaiian Islands. But very few of them were preceded by an earthquake. The city of Hilo on the Big Island has been dubbed the tsunami capital of the world. Dozens of these enormous waves have hit these beautiful islands, and the mystery is why. With no natural warning to go on, the people of Hawaii must rely on the world's biggest tsunami monitoring station. Set up in 1949, it is connected to a network of buoys spread across the Pacific Ocean. These buoys provide important clues. They monitor changes in sea level that indicate the approach of any potential tsunamis. In 1960, scientists got the breakthrough they were looking for. They were finally able to work out the type of event at the root of Hawaii's mystery tsunamis. An enormous quake on the coast of Chile, the biggest recorded of all time with a factor 9.5 on the Richter scale, triggered a tsunami that swept across the entire Pacific Ocean in just a few hours. The islands of Hawaii were thousands of miles away, directly in its path. The Tsunami Warning Center was monitoring its progress, revealing for the first time that a single massive wave crossed thousands of miles of ocean. The warning center was a success. They were able to evacuate the communities closest to the shore before the wave struck. But the homes they left behind were decimated. In Hilo, the tsunami was so strong it even bent parking meters in half. The wave continued past Hawaii to Japan. It had lost none of its power. Pacific-wide, this tsunami cost more than 2,000 lives and caused millions of dollars worth of damage. Devastating as it was, the 1960 event was a turning point in the study of tsunamis. It was the first time that scientists could accurately measure how the size of an underwater earthquake directly affected the size of a tsunami. And conclusive proof that a tsunami can travel thousands of miles across the Earth.
And it was with this Chilean earthquake that we really could prove that the undersea motions associated with the earthquake are generating these huge effects.
Now, scientists had the evidence to confirm that undersea earthquakes were directly responsible for tsunamis. The ancient Japanese suspicion was now scientific fact. In terms of modern tsunami study, the 1960 wave was year zero.
The Chilean earthquake was, you might say, the perfect storm. It's when scientific understanding had advanced to the point where scientists had begun to see the link connecting everything. So it's a new science. We're talking about something which is really only less than 50 years old.
There are more tsunamis in the Pacific Ocean than any other. So in 2004, the world was taken by surprise when one of the largest recorded tsunamis of all time took place in the Indian Ocean. On December 26, 2004, Indonesia was rocked by the second largest recorded earthquake ever, 9.2 on the Richter scale. Minutes later, a 90-foot tsunami slammed into the Southeast Asian coastline. 225,000 men, women, and children lost their lives.
The Indonesian earthquake had as much energy in it as the total energy consumption in the United States in 1 year.
This enormous burst of energy had been released in just seconds. Once again, the world had been reminded of the Earth's awesome power. In the last 50 years, scientists were finally able to confirm a solid link between earthquakes and tsunamis. By monitoring the size of the Chilean earthquake in 1960, scientists were able to prove conclusively that earthquakes triggered these gigantic waves. By following the path of this tsunami, they were able to prove that a tsunami could travel thousands of miles from its origin. Monitoring the earthquakes that caused this incredible devastation involves looking many miles underground. By investigating the power at the root of these giant waves, scientists can begin to figure out when and where these waves may strike next. These dramatic pictures of the aftermath of the 2004 Indian Ocean tsunami show the havoc a tsunami can unleash. It's almost impossible to imagine something like that happening here in the Pacific Northwest. But Professor Brian Atwater believes that events like the 2004 tsunami could one day happen right here, too. He was intrigued by early settlers' accounts of Native American folklore tales that spoke of great waves sweeping inland. They convinced him that huge locally generated tsunamis have struck here before and could strike again, posing a threat to tens of thousands of people living on the Pacific Northwest coast. To find out if he was right, he needed to uncover evidence of past giant waves hidden in this landscape. To be really sure it's a tsunami, though, he would also have to find evidence of the earthquake that caused it. Atwater's starting point is the Copalis River in Washington state, just a couple of miles from the long sandy beaches that make this area a thriving tourist resort. In the banks of this estuary lie buried thousands of years of history. This is one of the dirtiest jobs in science. Hunting for evidence of earthquakes is a muddy business, but it's worth it. Atwater has found signs of a potential tsunami.
There's a clue in this bank that nature has provided. It's this notch. And notches like this are common where tsunamis have laid out sheets of sand, and then later currents and waves come along and they pluck the sand grains out of the bank, but they leave the mud.
Atwater has to dig deeper to find what he is looking for. A layer of sand that could have been swept miles inland by a tsunami.
Okay, so now you can see the sand. What deposited this sand? Maybe it was a tsunami.
To prove that this was sand from a tsunami, Atwater's muddy quest must continue. He also needs to find proof that the land here around the river has moved up or down, a sure sign of an earthquake. After some hard work, Atwater finds what he has been looking for: clear evidence of both an earthquake and a tsunami. This time, there was a human cost as well.
Here we have evidence for abrupt lowering of land. We also have evidence for the associated tsunami. In this case, humans are involved. This was a fishing camp. Here you have the remains of that fishing camp in the form of fire-cracked rocks, the rocks were used to heat water mainly. Okay, so fishing camp overrun by tsunami. Because the land dropped after the tsunami, the tides came in and covered the fishing campsite and made sure that people wouldn't use it again.
The land the fishing camp was built on was dragged down during the earthquake. The tsunami deposited sand over the remains, and finally the tide covered the settlement with mud, where it remained undisturbed until now. Atwater finally had the proof he needed. His Native American myths of giant waves were no mere legend. But what was it that caused the earthquake? The prime suspect lay 50 miles offshore, the Cascadia Fault. Cascadia is a major weakness in the Earth's crust. Although the Earth may seem to be a solid sphere, Beneath the oceans and continents, it is divided into 8 major and many minor segments known as tectonic plates. Where they meet, they can grind and jostle against each other at fault lines, causing earthquakes. Geologists had long thought that the Cascadia fault line was incapable of generating a major quake. But Atwater's investigation has proved that it was highly active. The big worry for Atwater and the thousands of people who live in this region is that the Cascadia fault line bears an uncanny resemblance to another highly active fault line, the Sunda megathrust. It was an earthquake along this fault that was responsible for the Indian Ocean tsunami that killed nearly 250,000 people.
Where we get 2 tectonic plates coming together, such as the case of the Indonesian tsunami in 2004, one plate pushes beneath the other plate and creates lots and lots of friction and tension and drags the upper plate down with it. And that process can take hundreds of years, even thousands of years. It's a very slow process. But eventually, the pressure of this one should push back up again, wins, and it flips like that. And that creates a megathrust, a sudden movement of the seabed, and that's what creates a phenomenal tsunami.
2 factors made this Sunda megathrust earthquake so deadly. The first was its size. At factor 9.2 on the Richter scale, this was the largest in nearly 50 years. The second was that it took place not far below the surface.
When we talk about a megathrust, that's really where the seabed is disturbed dramatically. Sometimes, if the earthquake is deep in the Earth's crust, then you see very little surface manifestation of that earthquake. If it's quite close to the surface or very intense, then quite often you'll see the seabed itself moving, and that's what creates a powerful tsunami.
Investigating the ocean floor after the quake revealed that more than 1,000 miles of fault line had fractured and sprung up by 60 feet. This massive jolt pushed up billions of tons of water, enough to cover Manhattan to a depth of nearly 5 miles.
The lift zone itself was about 1,000 miles long. We had this entire stretch of subsea moving, which creates a huge wave. So the whole thing was a phenomenal size, and certainly one of the biggest tsunamis in living memory.
Atwater's determined research showed that the Pacific Northwest was at risk from this level of devastation too. But he didn't want to unnecessarily alarm the coastal inhabitants until he had collected all the evidence he could. Atwater needed to find out precisely when this tsunami struck this coastline to see if there could be more. He first tried radiocarbon dating the soil along the Copalis River, but the result could only take him so far. They showed that the earthquake and tsunami occurred somewhere between 1680 and 1720. More importantly, Atwater still needed precise evidence of how big it had been. But so far, his investigation has uncovered 2 extraordinary facts. By unearthing the abandoned fishing camp, Atwater could see that a Cascadia earthquake here had caused the land to drop. The notch in the bank was proof that this same earthquake had generated a tsunami. But what these clues didn't tell Atwater was just how big the tsunami was. He had no way of pinning down the size of the threat to the Pacific Northwest. His investigation was about to take an unexpected turn, with clues coming from not only thousands of miles away, but also from hundreds of years ago. Japan has the oldest record of tsunamis of anywhere in the world. Samurai writings told of a huge tsunami in 1700 that had swept over the east coast of Japan. It hit without warning and destroyed entire settlements. Japanese scientists were baffled as to where this wave had come from. There had been no earthquake to warn the villagers to make for higher ground. The mystery wave was dubbed an orphan tsunami. Back in the U.S., Brian Atwater's investigation into the mysterious Cascadia earthquake and tsunami needed more evidence. He had no accurate way to pin down either the size or the date of the event. All he knew was that it had taken place sometime between 1680 and 1720. But Atwater's dates were a revelation to the Japanese scientists. Could this event be the birthplace of their 300-year-old orphan tsunami?
And they said, by the way, we have this tsunami we've been trying to find a home for in 1700. So we think your earthquake happened in 1700, specifically in the evening of the 26th of January 1700, and it was of magnitude 9.
A Cascadia earthquake that produced a wave with enough power to cross the entire Pacific Ocean to Japan would have had to be a factor 9 at the very least. This is roughly equivalent to the enormous Indian Ocean earthquake. Earthquakes like this have so much power that they can send a tsunami across an entire ocean with ease.
The amount of energy involved is very hard to estimate. It's hard to put it into sort of terms that people can understand. We are looking at the phenomenal forces of several Hiroshimas, hundreds of Hiroshimas in fact.
But tsunamis are not just a very big wave. They're fast.
The big difference is the scale of the wave. It's typically 300 or 400 miles long. It's also not very high. When it starts off life, it's usually about 2 or 3 foot high. But it's moving very fast. It moves at a speed determined by the water depth. The deeper the water, the faster it moves. So in the deep ocean, this wave is moving at over 500 miles an hour.
Deceptively, as a tsunami speeds through deep water, it may appear completely harmless and scarcely detectable. Close to shore, the wave becomes a deadly killer. It is only then that a tsunami's true power becomes clear.
As the wave gets to shallow and shallow water, as it approaches a coastline, the wave slows down. The shallower the water, the slower the wave. So it goes from 500, 400, 300, 200, much, much slower. The back of the wave is still going full speed, and so the whole thing piles up. And that's why tsunamis are so destructive.
It is this immense speed and power that reveals how events here in Cascadia could devastate a coastal village in Japan. How an earthquake in Chile could decimate Hawaii. And how the Indian Ocean earthquake could kill almost 250,000 people. If a quake like this happened in Cascadia, the damage it would do to the Pacific Northwest coastline would be catastrophic. But to be sure about the scale of this threat, Brian Atwater has to be 100% certain that the dates of the 2 tsunamis were the same. After fully exploring the estuary of the Copalis River, he found one site that might hold the information he was looking for: a ghost forest.
The spruce root marks the remains of a forest that includes the ghost forest behind us. It dropped down into tidewater during the Cascadia earthquake. This ghost forest is made up of the standing dead trunks of western red cedar, and they were killed on account of the land here dropping, and then tides coming in and surrounding these trees and bringing in salt water.
This area would once have been covered with a dense forest. But today, only the bleached trunks of the rot-resistant western red cedar remain in place. When Atwater and expert tree ring specialists cut them open and studied the lines of growth inside, they finally cracked the 300-year-old tsunami puzzle. The dates of the Japanese and Cascadia events were exactly the same. January 1700. The Japanese orphan tsunami finally had a parent.
Maybe there's a certain amount of justice to it that a place that doesn't have written records has these outstanding geological records.
The link between the two events made it certain that the Cascadia earthquake had been at least an awesome magnitude 9. And ominously, it is almost certainly not the only time that Cascadia has rocked this area. Atwater believes he has found proof of a whole series of tsunamis stretching back 5,000 years. Each layer of sand in this sample represents a separate tsunami.
There are places at Cascadia where I've seen 9 stacked up in a column about 20 feet long. 9 buried soils, some of them coated with little sand sheets. And you say, okay, it's not a question of if, but it's just a matter of when.
Atwater's tireless detective work alerted officials to the increased tsunami threat. As a result, the towns along the Washington state coast have been able to prepare for this potential catastrophe. If a Cascadia quake occurred, the first waves could arrive here in just 25 minutes. Tsunami warning signs line the roads, and sirens stand ready to warn of an approaching wave. The lives of thousands of people are safer thanks to the work of Atwater and to some 300-year-old Japanese writings.
This is a hazard that shows its face often enough for us to take precautions to fasten the seatbelt against it.
By dating the ghost forest along the Copalis River to precisely 1700, Atwater had the final proof that Cascadia was capable of creating a Pacific-wide tsunami. Uncovering the multiple layers of tsunami debris in the riverbank dating back 5,000 years show that monster waves have struck here many times. This is an ongoing threat. Atwater knows that another earthquake is due here, but he has no way of knowing exactly when. Back in the Indian Ocean, the site of the world's most lethal tsunami in 2004, one man has taken the investigation of tsunamis to a new level. He believes that he has found a way to make the Earth's fault lines give up their secrets and accurately predict when the next deadly tsunami could be on its way. The idyllic-looking Mentawai Island chain in Indonesia hides a violent secret. One that makes it today one of the most dangerous places on Earth. These islands lie directly on top of the Sunda megathrust, south of where the enormous Indian Ocean earthquake triggered the 2004 tsunami. The Sunda megathrust is one of the largest fault lines on the planet. Since it caused the 2004 earthquake, it has also become one of the most notorious. Predicting earthquakes here is tricky, but Professor Kerry C. has a good track record. He has successfully forecast 2 along the Sunda megathrust already. The key to successful tsunami prediction is to forecast when and where earthquakes will strike. To do this, scientists must look into the past.
If you want to answer questions about earthquakes that only happen every few hundred years or a few thousand years, well, you've got to find some geological instrument that allows you to see those earthquakes.
Professor C has found an unusual way to unlock the secrets of the Sunda megathrust's turbulent history. Corals. These coral atolls are built from the limestone skeletons of millions of tiny creatures. Each generation builds on the remains of the last. Over time, the atoll gets bigger and bigger. As long as the corals remain underwater, they flourish. But once they're above water, they die. Earthquakes are responsible for killing all the corals stranded above water on this beach. This beach contains corals of many different ages. Altogether, Professor C has nearly 1,000 years of history at his fingertips. But to unlock the secret history the corals contain, he and his team have to take a less than delicate approach.
We're looking at a saw cut that we just made through a coral micro-atoll. And the great thing about this head is it records a sudden drop of about 1.5 feet down to here. It died down to here because the island rose. The new low tide is way down here. Everything that was so bold as to grow up this high dies.
The shape of the coral records the fall of the Mentawai Islands as they are literally pulled down by the Sunda megathrust. But crucially, the corals also record the moments when the islands are thrust up out of the water during an earthquake. Between quakes, the islands are once again pulled down by the fault in a never-ending cycle.
You have to imagine that rocks actually are elastic. Take a diving board. The diver walks out on the platform and it bends like this, and then he jumps and he springs up and he jumps off. And when he jumps off, the diving board doesn't stay here. It doesn't go like this. The diving board springs back up. It's elastic. Well, rocks are the same. Rocks are elastic too. So when the Indian plate goes down, it pulls the Sumatran section down too, and then later it fails. So it just springs up like a diving board.
By analyzing corals all over this beach, Professor C has discovered a regular pattern to this cycle. A major earthquake rocks these islands roughly every 200 years.
What we have here in Sumatra with the corals is what I call the holy grail of earthquake science, of paleoseismology, and that is a long record that has many cycles in it, a 1,000-year-long history of earthquakes.
But when the geologist looked even closer, he saw that the cycle was more complex.
But when we cut a slab, we can see it in much more exquisite detail because we can see what we call the stratigraphy, or the layering, and how the layering relates to the changes of the tide. So what we can see over here then is the annual bands of growth right here. So there's about 10 years between this earthquake and this earthquake.
Professor C had discovered a major clue. The corals record that not only does a major earthquake and tsunami hit here every 200 years, but that they are always accompanied by a number of smaller quakes. This is a cycle within a cycle, a supercycle. And by counting back the layers of growth within the coral, the geologists can put an exact date on all of these earthquakes.
We know there's a sequence in the 1350s, 1370s. We know there's a sequence in the 1560s to 1600. We know there's a sequence 1797, 1833. Those sequences are about 230 years apart.
This is crucial information for the people of the Mentawai Islands, who have no written history. But Professor C's work doesn't stop here. By uncovering their history in the corals, he believes that he can now predict the future for these islands. And he's already had some success. Professor C began his work here in 1993, and soon realized an earthquake was imminent. The Mentawai Islands were about to start their next deadly supercycle.
Okay, experience an earthquake.
In September 2007, he was proved right, when an earthquake shook the islands just enough to generate a small tsunami that wrecked homes and schools. History is repeating itself, exactly as he predicted it would. A much bigger earthquake and more dangerous tsunami could be due any day.
One section hasn't failed since 1797, so since George Washington was President of the United States. We know we're now in a sequence of at least 3 giant earthquakes. We're expecting another one. The question is whether the earthquake and tsunami will be in the next 30 minutes or the next 30 years.
Thanks to C's research, the people of these islands have had time to prepare. When the wave comes, they will be ready.
Earthquakes are forecastable. If you have enough information about how they've behaved over the last 1,000 years, or 2 or 3 or 4 cycles, you can really make a significant forecast that people living in the area actually can do something about.
Education is key. Children here are now taught that as soon as they feel the shaking of an earthquake, they should run for higher ground. Newly built roads snake up steep hills from waterside villages to allow rapid escape from the deadly waves.
I'll bet that young children alive today, certainly if they live to be 60, they're going to see that earthquake. And in fact, I think there's a better than 50% chance that it'll happen within the next 30 years.
By analyzing the shape of the corals on the Mentawai Islands, C has proved that a major tsunami cycle starts here every 200 years. By dating the lines within the coral, he can be even more exact. They show that these cycles contain not just one, but several deadly tsunamis. The Sunda megathrust is the clear culprit for tsunamis here. But not every tsunami is generated by an earthquake. A rarer, different type of wave is out there. A mega tsunami. Although earthquakes are by far the most common cause of tsunamis, there is another source for these deadly waves: landslides. And these tsunamis have the potential to be so big that they have been called mega tsunamis. Scientists had long suspected that waves could be generated in this way, but conclusive photographic proof wasn't available until 1958. A landslide into Latoya Bay in Alaska triggered a wave that reached heights of several thousand feet. This footage, shot just after the tsunami struck, shows the wave's enormous power. The trees here once stretched all the way down to the shores of the bay, but were ripped off the slopes by a wall of water, leaving nothing but bare, exposed rock. The tsunami was generated when a relatively small earthquake triggered a single enormous landslide of rocks and debris into the bay. The resulting wave was higher than the Empire State Building and stunned scientists around the world. Tsunamis on this scale are incredibly rare. But another mega tsunami, triggered by a rockfall 10,000 times bigger than Latoya Bay, could be on its way from a small island across the Atlantic Ocean. The Canary Islands off the coast of Africa are formed from a series of volcanoes. The youngest is the island of La Palma. It is formed from two volcanic ridges. The first is the extinct Cumbre Nueva to the north of the island. The younger, active Cumbre Vieja lies to the south. It erupted as recently as 1971. Geologist Dr. Simon Day's research was crucial in developing the La Palma megatsunami theory. It began with an unusual rift that had opened up during a major volcanic eruption in 1949.
We're standing here in the fault, and it runs way down to the south along the crest of the volcano for 2.5 miles. So it's one continuous long structure.
Day believes this fault is evidence of a geological time bomb, the beginning of a giant landslide.
What we see here to my right are layers of volcanic rocks, volcanic blocks here, and layers of volcanic ash. And on the west of the fault, we see the same layers of blocks and ash, and those, before the fault moved, were joined up, and then when the fault moved, they were separated, and the rocks to my left moved down and to the west. What we think will happen in some future eruption is that this fault will have gotten bigger, and the whole of this western side will slide away in a giant landslide into the ocean to create the tsunami.
This landslide would send the entire southwest section of La Palma, 1/6 of the island's total mass, crashing into the Atlantic Ocean in a single giant landslide.
What we envisage is the whole of this coastline and the slope extending up all the way to the crest of the volcano that is now in the clouds. All of that mass of rock would slide away in a single massive landslide into the ocean and pushing the water up in front of it to create the tsunami wave.
Initially, this wave would be over 30 times bigger than the 2004 Indian Ocean tsunami, more than 3,000 feet high. The 1980 eruption of Mount St. Helens was proof that a volcano could collapse in this terrifying fashion. This was impressive, but the collapse of the Cumbre Vieja would be 200 times the volume of this. 1,200 billion tons of rock would hurtle towards the ocean at top speed. The resulting wave would head straight out into the Atlantic.
That wave, of course, would then spread out and separate out into smaller waves. But even so, after crossing the Atlantic and piling up again on, for example, the eastern seaboard of the United States or in the Caribbean or in northern Brazil, the waves there, we predict, would still be between 30 and 100 feet high. So that's as large as, if not larger, than the tsunami that struck Sumatra in 2004.
Boston. New York. Even Miami could all be under threat from the giant waves. This was a bold prediction. Day needed more evidence to back up his theory. As he was about to see, the rift in La Palma's landscape was far worse than he expected. The 1949 eruption had left a different type of geological scar on the island. Evidence of a more serious weakness within La Palma came from a series of eerie-looking lava flows dotted across the island.
One of the characteristics of the 1949 eruption that's unusual is that instead of starting at one vent and just continuing there, a series of volcanic vents opened up in different parts of the island.
When Day plotted these weaknesses on a map, he came to a frightening conclusion. The rift was far bigger than he had first suspected.
The area that's potentially affected is very much greater than the length of the fault at the crest of the volcano would indicate, extending out 10 or 15 miles from the crest out to sea.
This growing body of evidence proved that the rift wasn't just a mere crack in the surface of La Palma, but a deep fissure that reached hundreds of feet down into the island's foundations. It is La Palma's volcanic heritage that is the key to this tsunami threat.
The big hazard here isn't the eruptions themselves, it's the fact that the volcano is building up over time and becoming more and more unstable, so that will eventually lead to a collapse.
And it seems that this is not the first time a La Palma eruption may have triggered a giant landslide. Proof lies in the north of the island, in these sheer cliff faces, formed 65,000 years ago.
What we see in the north of La Palma is the landslide scar left when the old volcano in the north of La Palma experienced a giant collapse and produced a giant landslide off to the west. So that was a huge collapse. It removed as much as 100 cubic miles of rock and deposited it out into the ocean. So it's the sort of event that we think is going to happen again in the future at the Cumbre Vieja.
This ancient collapse of the old Cumbre Nueva volcano is almost certain to have generated a gigantic wave. And the next collapse might not be that far away. This tsunami could strike in our lifetime.
Even though it seems so extraordinary when we consider it in human terms, and we talk about a tsunami striking the east coast of North America and causing huge devastation on the scale of the Sumatra tsunami, but this is what happens in the geological record. This is what Earth does.
Although tsunamis have been documented for thousands of years, it is only in the last century that geologists have been able to prove how they are connected to the movements of the Earth. By analyzing data from the Great Chilean Earthquake of 1960, scientists were finally able to firmly link earthquakes with tsunamis. Unearthing buried Native American settlements proved that the Cascadia fault line in the Pacific Northwest was an active tsunami threat. Corals in the Indian Ocean proved that some earthquake-generated tsunamis follow a pattern and strike the same area with regular intervals. And the giant rift in La Palma's landscape shows that tsunamis generated by landslides are also a very real threat. Mega tsunamis, which could prove to be the biggest waves that threaten our coastline. Tsunamis are an inevitable part of Earth's dynamic structure. Their capacity to destroy is awesome. But as scientists begin to understand more about the origins of tsunamis, they are coming closer to predicting where and when these monsters may strike.